Welcome back, Flare community. In today's video, we're going to look at the first part in a layer cake deep dive. Now, layer cake is basically a way that the Flare network are building better bridges. It's basically a bridging system between various smart contract networks with many different benefits in comparison to the traditional bridging solutions. We're going to jump straight in today and let Hugo introduce us to layer cake and give us a little bit more information of what it actually is. Let's jump in.
So layer cake is our most recent innovation. And the most important thing is that it's a bridging system for smart contract networks. Not just to Flare from another smart contract network, not just from Flare to that smart contract network, but between all smart contract networks. So allowing you to bridge from Ethereum to Solana, from Cardano to Near, from Cosmos to Ethereum, from Terra to Flare, anywhere you want, in any direction, with unified liquidity. And that's really, really powerful. And so what I'm going to do now is take you through layer cake, in a relatively deep dive. Hopefully you'll find it interesting. So these are the key components of layer cake. I'm going to go through three things: speed and safety, the risk of chain reorganization, and scaling linearly versus quadratically. And what that means is not using bilateral bridging, and we'll come on to what that means and why it's interesting. So speed and safety, how to build fast, decentralized, and fully insured bridges. If you want to build a bridge between two chains, let's say chain A and chain B in this example, you need to have smart contracts on both sides and a relay system in between. And that relay system has generally been defined, and it's called a light client relay. And what a light client relay is doing is it's running a lightweight node on both the chains. And it runs a lightweight node because the cost of running a proper node is hard. And what it's doing is it's relaying the block headers between each chain. Now, the problem with only relaying the block headers is that you don't get the full richness of the data of the block. And so if you're only relaying the block headers, then you need to do a lot of additional checks. You need to do things like erasure encoding and data availability sampling to ensure that you're not being lied to about what you're seeing. And so the problem with the existing example of a trustless decentralized bridge is that they can only operate safely if they're operating slowly. There are other problems with this, but this is outside the scope of this presentation. And so this means two things. Decentralized transfers can only be done slowly, and this is really poor for usability. And the second thing it means, which may be more important actually, is that the relay model means that decentralized bridges have to be bilateral rather than multilateral. And that fragments liquidity. We'll come on to what fragmenting liquidity means shortly. It's a seriously big deal. And that's why, largely, bridging has been done by centralized bridges, multi-sig based bridges. So how do we propose to build a fast, decentralized, and fully insured bridge? Well, unlike a relay, the state connector on Flare can safely acquire the state of another chain. And it does it without just using block headers. It has all of the rich data from the block itself. And this is really important. And secondly, Flare is actually coming to consensus over what has happened on chain A in this example and chain B. And this lets us employ a mechanism to secure a fast moving bridge that uses Flare to secure it. And so this brings us on to the role of bandwidth providers in the layer cake system. So let's take the example of a bridge from Ethereum to Solana that's bridging Ethereum to Solana. Bandwidth providers are the entities that operate the layer cake bridge. You don't have any trust in them. There's no reliance on them, and they're not holding your money. They just enable the bridge to speed up. And so for the first step, a bandwidth provider will mint slowly and securely onto Flare some amount of Ethereum to support the bridge. And in this example, I've said that the cumulative amount of Ethereum that is minted onto Flare is 500. And so what that 500 Ethereum means is that this is the maximum amount that can go across the bridge at any one time. And the way that is enforced is through smart contract. And so Flare receives this 500 Ethereum. It sits in the Layer Cake smart contract on Flare. And then Flare then communicates to both the smart contracts, the smart contract on Ethereum and the smart contract on Solana. And it says to those smart contracts, the bandwidth is 500 Ethereum. No more than 500 Ethereum may move between the bridge at any one time. So you may not remove more than 500 Ethereum from the Ethereum smart contract. You may not remove more than 500 wrapped Ethereum from the Solana smart contract. And this is really the crux of how Layer Cake works. And that we've specified this period as 1 hour initially, as we think that's a good amount of time for the whole system and the community to be able to observe what is happening on the bridge and for it to be shut down should there be any issue. Now, the bandwidth providers, having supplied 500 units of ETH as bandwidth, now operate the bridge. And a user comes to the bridge contract on Ethereum, gives it some ETH plus a fee that the bandwidth providers receive, and they get Solana ETH on Solana. The bandwidth providers under the Happy Path enable that to happen. Now, if the bandwidth providers are dishonest and mint for themselves, the total loss from their dishonesty can only equal the amount of bandwidth held as collateral, held on Flare as collateral. And this is what we mean by insurance. The bandwidth providers are able to move a certain amount of Ethereum between the bridges. And if they steal that Ethereum in the moving of it, then the amount held as collateral is used to reimburse the contract. And it reimburses the contract 100%, not 90%, not 50%, 100%. Because the contracts are limited by how much bandwidth is provided as collateral. Additionally, the dishonest bandwidth providers can be removed very easily from the system. And most importantly, if all the bandwidth providers are dishonest, or they all disappear for some reason, their computers go down, the whole system doesn't freeze, it doesn't stop working, it doesn't disappear. It just reverts to being a slow relay-based system. And so that means your funds are never lost to you. It also means that no one is in control of your funds other than these decentralized networks. And it's all insured on Flare. And so let's just very briefly look at the example of most bridges today. So all they're really doing is putting a group of signatories between two chains. In this example, Ethereum and Solana. Let's say they have 3 signatories. Let's say they have 10 signatories. It doesn't really matter how many signatories they have. It's not decentralized. They have signing rights over 100% of your capital, and they control all of that capital. They can steal it, or more generously, when they get hacked, the losses to the contract are unlimited. There's no insurance mechanism. There's no speed limit, which is bandwidth in our example, and there's no insurance, which is the bandwidth collateral in the Layer Cake system.
So there we have it, the first part in a 3-part series of the Layer Cake deep dive, as described by the Flare CEO himself, Hugo Philion. Layer Cake functions as a bridge between various smart contract networks. In this video, we learned that Flare's solution is far ahead of any current bridging system. We also learned that bandwidth providers are the entities which operate the Layer Cake bridge. The collateral provided by bandwidth providers is locked up in the Layer Cake smart contracts, and this provides users with 100% insurance, meaning in the unlikely event of an exploit, users will always be fully reimbursed with their funds. This is a revolution happening before your very eyes. Flare is providing a glimpse into the future of blockchain and how it will connect everything. In part 2, we're going to look over another safety mechanism of layer cake, and that is the prevention of chain reorganization. I really do hope you enjoyed this video. Please feel free to like and subscribe if you haven't already, and if you want to take your support to the next level, be sure to check out the Patreon link in the description for entry into this week's Songbird giveaway. Thank you all so much for watching. Please enjoy the rest of your week, and until next time, I'm out.
Mission Control, we have liftoff.